Alaikum warahmatullahi wabarakatuh. It's unfortunate not to meet you face to face, but still we can contact each other. Our topic is wastewater engineering 4043. This is my name, this is my telephone number. You can contact me anytime. I will answer your question, inshallah, no problem. Okay. Wastewater engineering, we have many topics: an overview, objectives, methods, and implementation consideration. We start with wastewater treatment, sludge disposal and reuse, wastewater reclamation and reuse, effluent disposal, the role of the engineer, because you will be engineering technologist, so you have a big job to do. Wastewater treatment objective and regulation, classification of wastewater treatment method, selection of treatment processes, flow diagram, because here different waste needs different treatment method. Okay, and then implementation of wastewater management programs. In the past, as is for small villages and small community, when a small amount of sewage are discharged into the open environment, natural process of stream self-purification occurs. That is normal. The main idea is here dilution will occur and small amount of waste then will not be a big issue because biodegradation or photodegradation will do the job. However, in big community like what we have here, for example, you have big city, dilution will not do the job. So we need to make like sewage system, and this sewage system will be designed by, as you see here, civil engineer. The job of this civil engineer will lay out the design and then how to bring this waste from homes to the river or to the sea or to the wastewater treatment station. After that, his job already finished. Starting from here, very happy that he already has his job. Okay, but environmental engineer, we will think about how we can treat this waste, what units needed, what kind of waste. Based on that, how we can select the suitable treatment method. Okay, finally, we will get here, as you see, clean water and eco-friendly can be used, no problem, because we already remove all toxic components and then became safe for disposal. Okay, we define the beginning. What is the wastewater? It is the negative results of human influence against the aquatic ecosystem. This is the best definition I found actually. Example: use potable water, domestic sources, commercial and industrial sources, storm water, groundwater. Previous sources may contain pathogens like bacteria, viruses, and we have a big virus, COVID-19. That is a big issue. We cannot meet because of that. Degradable, non-degradable organics, and then nutrients, P and C. This usually comes from food waste. Okay. Inorganic contaminants like heavy metals, NO3, nitrite, nitrate, and ammonia, and other than that, solids also. The history of wastewater treatment started for example, in 1900 to early 70s. The focus was paid to suspended and floatable material, and also biodegradable organics, plus also pathogens, because this is bacteria and also viruses we need to clean before coming to the homes or to factories or whatever. From 70s to 80s, the thing became more. So here, environmental concern like waste coming to damage the ecosystem, or called aesthetic problems. Then nutrient removals, and then widespread treatment of wastewater. In 80s, start another issue began, which is toxic compounds like heavy metals and endocrine disruptors, and then dioxin, etc. So every, starting with small things, now became more complicated. Now we are trying to solve problem of COVID-19. This is also maybe somehow impact from environmental problems. Impact on environment, pathogens, drinking water, bathing, oxygen depletion. We will talk about this because this make eutrophication here, especially in the sea water. Turbidity, silt buildup in receiving water, toxicity to ecosystem and human. Let me define you the effluent, how it looks. When we are talking about effluent, we are talking about, for example, this is septic tank in the homes in village. So this is all underground. Waste coming from home, from kitchen, from toilet, whatever, it goes to the septic tank, the main. So here will be the effluent, and after going out, this will be the effluent. This will be, because it is covered underground, will be treated by microorganism, or it is biodegradation. For small amounts, not a big issue because also filtration and everything in the earth crust, and then go to the underground water somehow clean because small amounts and there is dilution in every stage, so not a big issue. In the cereal area, how to define the effluent disposal concept? You see, this is the effluent. So we make at the beginning preliminary treatment. What is preliminary? It is mostly physical treatment. As you see here, this is physical treatment, like screen, grit chamber. We'll talk about this in detail in the future. Huh? Don't worry about this. Okay, then we go to primary clarifier. So clarifier here, we take the solids and then we release the water. And then we go to secondary. Secondary will be before aeration, maybe there is some coagulation. Coagulation, if there is suspended solid, will be gathered and precipitate. After that, we go to aeration. This is aeration, we add oxygen. This oxygen is very important for bacteria to use and consume organic compounds and then produce gases. But with this will form sludge, this sludge. Okay? And then go to secondary clarifier and then finally to chlorine as disinfectant and effluent. Okay? Here sludge will be treated also. Finally, we get dewatered sludge. This dewatered sludge, if it is from food waste, it can be used as fertilizers. Okay, but here part of this water, clean water, will go back recycled because this is rich with. There is some sludge here, which is rich with bacteria, which is very important to go for aeration tank. Okay, hopefully you understand what is the meaning of influent and what is the effluent. Influent is the entrance of the waste or stream of the waste at the beginning before treatment. Effluent is the stream of water after treatment. We go to very easy, simple activated sludge process. What is because this is usually used in wastewater treatment. So we go homes or industry, there is a waste, and go here to a big tank or reservoir or whatever. Then we inject air, pumping by pumping air here, and then aerobic digestion will be here. It means that bacteria will do the job to eat hydrocarbons and other components, so that gas will be released, and then sludge also here will be formed. When we bring to clarifier, we separate sludge from clean water. If this sludge, as I mentioned before, rich with nutrients like hydrogen, like phosphate, like nitrogen, then it can be used as fertilizers. Wastewater reclamation and reuse. Reclamation of water is the process of converting water or wastewater into water that can be reused for other purposes. Reuse may include irrigation, industry, aquaculture, etc. In many locations in the world, available water or fresh water became inadequate to meet water need. Therefore, collected this water and used one more time. Okay. In this case, we don't consider this as a waste. We consider as resources, as you see here, that must be reused. especially in Middle East and Africa. This we have shortage of water, so this will help at least in irrigation and other purposes. The use of dual water systems, such as now used in some area, is expected to increase in the future, so that treated effluent is used for landscape watering and other non-potable uses. Potable means that drinking, not for drinking. There are different methods for wastewater treatment. Here, at least you have 5 wastewater treatment. This mainly for water coming from the river or from underground to the drinking to the houses. Methods very easy, as you see here. We will talk about each one in details. Okay. Second one is wastewater treatment. Number 3 is advanced wastewater treatment, and then recycle water, and then water reclamation. The first one, water treatment from river to the homes, very easy, not difficult, because here we take water pumping and then we add coagulant. This coagulant, if there is any nanoparticle size, will become big and precipitate. After that, go to settling tank where we separate sludge from clean water, and then go for more filtration, and after that, chlorination or disinfection process. It means that we are sure that doesn't contain any bacteria or viruses, and then goes to the homes. Waste coming from here must be treated, okay, through grid chamber, and then primary settling, and then biological treatment. Biological, either aeration or we call it aerobic or anaerobic. Aerobic, we add air. Anaerobic, in the absence of air. And then final settling, and then goes to the river or to the sea. Wastewater treatment here, you see coming, we have here anaerobic zone where bacteria will utilize the contaminants and produce nitrogen. Here also anaerobic also, because some bacteria will use as anaerobic, other bacteria will be like aerobic. And there is also anoxic. What is the difference between aerobic, anaerobic, anoxic, and oxic? We will talk in details in the next chapters. Okay? And then here aerobic zone. Aerobic zone, that oxygen will be utilized from air, because here NH3. But anaerobic, it means that we utilize the oxygen in the compound itself. So isolation of in the absence of oxygen. Okay, and then finally goes after nitrogen removal or phosphorus compounds and sludge removed, we can throw to the open environment. After we check that there is no heavy metals and other components. Here, advanced wastewater treatment, also somehow similar. Okay, it is not no big difference, but here is more complicated. If you go to recycled water, here like what we are using in our homes, like filters, reverse osmosis, it is more complicated. Okay, so here you have secondary effluent coming. You go to cartridge filter, and then micro filters, and then break tank, again cartridge filters, high pressure pumps, and then RO, and then disinfection, and then finally injection to the well, or goes to the river or to the sea. Okay. Wastewater treatment method, there are different methods. It's called preliminary, and this is description is here. I don't have time to read for all these things, but you can read slowly by your own. If you have any difficulties, you can ask me. What I want to ask is to focus on is how many treatment methods or levels we have. Preliminary. Preliminary or primary will be mainly for physical treatment. Advanced primary also, this is also like nano, for nano size particle, very small. And then secondary will be here. Secondary will be chemical, add coagulant or whatever. And then secondary with the nutrient removal, we have to add here bacteria and all those things. And then to advance, it means that microfiltration, nanofiltration, so that we make sure that there is no any contaminants in the drinking water. Here, unit operation and processes. We study different unit operation. Unit operation 1, unit operation 2. We study filtration. We study drying. We study screening. We study membrane separation. We study many chapters. But here, there are, for example, what kind of contaminants here, what kind of contaminants in this column, and here what kind of unit operation we can use to treat. Of course, there are different processes, there are different unit operations. This is just for knowledge to understand that there is no one method for treating all kind of waste. Depends on the waste, we have to select the suitable treatment method. Okay. What is professional engineer? Professional is competent by virtue of his fundamental education. If you read this slide, you will understand that a big task for environmental engineer or professional engineer in general, that he must be well educated in his area, specific area, plus also other areas, not only in his area, but more focus on his area, so that if any consultancy gave to him or given to him, he will be able to give recommendation and to solve this problem. Okay, so this professional engineer must be supported by knowledge and also experience. Okay, and then he can give a decision. Engineer professions, the majority of engineers fulfill the key characteristic of profession known as follows. They are required to expert in particular area. This I already mentioned before. You can read carefully here and slowly see what is okay, what is not okay. You can ask me through WhatsApp if you cannot understand here. The role of the engineer. What are the rules of engineer? Or we call it engineer roles and responsibility. Engineering encompasses science and art, mathematics and creativity models and approximations in solving real world problems. Now, when you go to the waste plant, real plant, you are not talking about theory. We are talking about real, how we can solve this problem. Engineers integrate their knowledge of the physical sciences with more abstract realms beyond the boundaries of current technology in all areas of life. Chemical and bioengineers are working on drug-related systems that work inside cells at the molecular level. And environmental engineers quantify the particle flow of pollutants through soil to clean up abundant industrial sites, oil spills, and other hazardous materials. Engineers have many different types of jobs to choose from, including research, design, analysis, development, testing, and sales position. Now we call it multidiscipline engineer. You have to have background in all these kind of things, not necessarily to be very in detail, but at least you have some idea how to manage. Okay, how to make development, how to make analysis, how to design. Engineer work also organized by traditional academic field of study. Engineers are problem solvers who search for quicker, better, less expensive ways to meet through challenges. Benefit for being professional engineer. The reason for choosing engineer as a professional career largely attributed to the perception of the job security and market demand, as Malaysia poised to become the industrial nation by the year 2020. This year. Okay, inshallah, we can achieve. But because of COVID, maybe it will be delayed for a while. COVID-19. Huh? However, several other reasons as follows can also contribute to the phenomena, namely job satisfaction, variety of career opportunities, challenging work, intellectual development, benefit society, financial security, prestige, professional environment, technological and scientific discovery, and creative thinking. All of this, there are details about this. You can, why job satisfaction is very important. Okay, what are the benefits from job satisfaction? If you are satisfied with your job, you can contribute more to the job, to the successful of the company or the university or whatever. So you work very good way so that you can achieve your job satisfaction. Okay. Thank you very much for the time used, and hopefully, inshallah, we see you in the next slide. Stay at home. Try not to go anywhere. It is very difficult time, but we have to also react in positive way. Wassalamu alaikum wa rahmatullahi wa barakatuh.